Hi, my name is Kent Lee and I teach computer science at Luther College. Okay, so in this series of videos we've been putting together a Frogger application, and we're now ready to get the frog to jump on some logs. So to get ready for this lesson, we'll open up Spotlight Search again, start up the terminal. From there, on a Windows machine you'll want to go to the Git Bash shell, and we'll execute these commands. So cd to change directory home, then we want to get into documents, then we want to get into programming, and then we want to get into Frogger. And to get ready for this lesson, we're going to do a get checkout, and it's -f, and this is lesson 10 that we're going to be doing now, so we'll switch to that branch. Once we get that done, we can open up Wing. And we should be sitting here with the lesson 10 code all ready to go. Okay, so the last time we were able to get hit, we were able to make sure that the race car did run over the frog. Now we're going to get the frog to be able to jump on a log. In a certain sense, it's a little similar to what we did with log, or with race car. We're going to add frog as a parameter to forward here to get this all to work. And then what we're going to do is we're going to write a method that's going to help us, or write a function that's going to help us determine whether or not the frog and the log are in the same vicinity. Now, distance isn't going to work for logs because logs aren't circles. Frog is kind of an approximation of a circle, so is a race car. But a log is long and skinny, so we're going to need to see if they intersect. And we're going to write a rectangular intersect then as a function that checks to see whether they've intersected the frog and the log. So we'll have our x1, x2, or y1, x2, y2, just like we had before. But we're going to use a technique here that's it's called a guess and check kind of technique. And what we're going to do is we're going to see if they're far enough apart in any direction so that they don't intersect. And if there's no way that they don't intersect, then they must intersect. So the first thing we're going to try is to see if y1 is less than y2 minus 20. This would say y is the up and down, so this would say that the frog is much below the log. In that case, they would not intersect, so we'll return false in that case. Then we're going to check to see if the frog is past the log. So if y1 is greater than y2 plus 20. And if that's the case, then again we're going to return false because the frog is above the log in that case. We're going to do the same with the x's. So we're going to see if x1, which is the frog, is less than x2, but in this case minus 60 because the log is about 120 long. So in that case, we're going to return false, that they don't intersect because it's way in front of the log, or way past the end of it. And likewise, if x1 is greater than x2 plus 60, then it's at the other end of the log, and so we're going to return false. If none of those relate, if none of those are true conditions, then we know that the log and the frog are pretty close together, and so we're going to return true. Okay, so you'll want to get that all typed in. That's quite a bit of code. You can pause it now and put that code in if you need to. Now that you've got that done, we can go back to log and we can use that code in there to see whether or not they intersect. So this is how we go about using that code then. So we're going to ask if they rectangularly intersect. If rectangle intersect, okay, and we'll pass in self.xcore as the first x coordinate, and then self.yCore as the y coordinate, and frog.xCore as the next one, and frog.yCore as the other. Okay, so then we know if those things intersect, the x coordinates and the y coordinates, then we're going to want to move the frog with the log. So I'm going to say that that's equal to true at that point. And else, this is an if then else, we're going to set move frog equal to false. Okay. So now we're going to go about changing the wrapping code here and the moving code, so that if move frog is true, that means that we need to wrap the frog with the log. So we're going to say frog.goTo, and we're going to get the x coordinate from the log here and the y coordinate from the log here as well. So we're going to tell the frog to wrap with the log if it's on there. Of course, in real life, the logs go downstream, but in our Frogger application, they're just going to keep wrapping around. We're going to do the same thing with the moving as well. So we're going to say here, if move frog, then we're going to say frog dot right by 90, because right now the frog is facing up, but we want to move it with the log. And then we can do frog dot forward, whatever the distance is, so that it moves with the log. And then we'll have to turn the frog back to moving back to the left again, so that if the up arrow key is pressed, that it'll move in the right direction. Okay, and then we got the distance there. So here we're going to move with the log, and here when it wraps around on the screen, we're going to put the frog right in the middle of the log when it wraps around. Okay, so let's give this a try and see what happens. And oops, forward is missing one required positional argument, and that was in log.forward2, and that was down here. Then we added frog to the forward, so we got to add the frog down here as well. Okay, and rectangle intersect is not defined. That's because I called it rectangular intersect. That's what I need to call it in here, rectangular. Okay, so now the frog is capable of moving through. I could get hit by those things. Don't want that to happen. When I jump on the log, I stay on the log and I move along, and when it wraps around, I'm in the middle of the log, and there we go. Okay, so this is all well and good at this point. We've gotten the frog to go onto the log, and the frog can get hit by the race car. And we'll move through the water at that point. Now, what we want is when the frog is in the water, if it's not on a log, then I think we want the frog to get eaten by a crocodile. And in a future lesson here, we'll put the crocodiles in the water, and we'll make the frog die if he's in the water and not on a log. So we'll take care of that in just a little bit. So reviewing the code that we have at this point, let's go back and review it. We've got rectangular intersect, and there's that code. You want to make sure that you've got that. Okay, and then going back to the class log, we changed the forward in the class log So there's our class log in its entirety. And we change the forward in here to call rectangular intersect to see if they intersect. And we set move frog to true if they do and false otherwise. And then we used move frog in two places. One here when we wrapped around on the log, and one here right before we moved the log. So we're going to move if we need to move the frog with the log, we'll move them in the same distance, same direction, and same distance forward. And then there was one other change, and that was down below where we are animating everything. We had to now pass in the frog to the log.forward so that we can move the frog if need be. And that's it for this lesson. So give that a try, see how it goes, and we'll move on from here in the next lesson.